Okay, today we're going to be talking about applying the power law to certain types of functions in calculus that have radicals or reciprocals, right? So for example, in the first term here, we've got a radical in the bottom. Over here, we've got a radical in the top. And over here, we've got a reciprocal function, 6 over x. Now, here's what you do for each of them. You have to rewrite each term so that it appears as a power. And what I mean by that is it has x to the power of something. Okay? So I have to rewrite each term before I proceed with the derivative. So on the bottom here, whenever you have a radical, you have to look at what type of root it is. So there's no number on the left here. What that means is it assumes to be a square root, 2. To rewrite this term in the bottom, this would just be x to the 3 over 2. Okay, so usually the type of root is, you're basically creating a fraction here as an exponent. And on the bottom of the fraction, the denominator, that is the type of root you have. So it's 2 here. The denominator would be 5 over here. Okay? And so the numerator would be 2. So this would be x to the 2 over 5. Now, here's the issue. You have x in the bottom. You always want to have x in the top if you're applying the power law. That's fine. So to put it to the top, all you have to do is move that x term to the top. So instead of writing 5 over x to the 3 over 2, you write 5x to the negative 3 over 2. So you can move it to the top provided that you change the exponent sign to a negative. It's called flippy switchy. You flip the entire power to the top, switch the sign. Done. Over here, on the right side, we have 3 over 2, and this can be written very simply as x to the 2 over 5. I don't have to switch any sign at all. And then the last term in the middle, this is the reciprocal function. There's an invisible exponent here of 1. Now, again, I can flip that to the top, and then this is just going to be minus 6x to the negative 1. And there's my power, right? There's my set of powers. So now I can take the derivative. If I take the derivative, how do I take the derivative using the power law? Well, I drop that exponent down and multiply. And so I get negative 15 over 2. And then it's x to the power of negative 3 over 2 minus 1. Now, negative 3 over 2 minus 1, if I'm using common denominators, is negative 3 over 2 minus 2 over 2. 2 over 2. So negative 3 over 2 minus 2 over 2 is actually negative 5 over 2. So this exponent right here is negative 5 over 2. So that's that. That takes care of that term. And then I'm going to proceed with the other derivative, the term next to it. So this negative 1 over here drops down and multiplies to negative 6. And you end up getting a positive 6. Now, this is going to be x, and the exponent is going to be negative 1 minus 1, which happens to be more negative, negative 2. Then you drop 2 over 5 down to multiply to 3 over 2, and you're going to get 6 over 10, which happens to reduce to 3 over 5. And then you're going to subtract 2 over 5 by 1. And so it's going to be 2 over 5 minus 5 over 5. 1 whole, right? And you get negative 3 over 5. And there you go. So if you notice, now in my derivative, I've got 3 terms with 3 negative exponents. So if I want to rewrite these with positive exponents, all I'd have to do is drop the entire power back down to the bottom and switch the sign. So it's a flippy switchy in reverse. 2x to the 5 over 2. Over here I'd have 6 over x squared. And over here I'd have plus 3 over 5x to the 3/5. And there you go. That is the derivative. So that is the derivative applying the power law to functions that have radicals as well as reciprocal functions. Okay? So basically that's the lesson. Thank you very much for joining me. If you enjoyed it, if you learned something, leave a like, comment, and subscribe, and I'll see you in the next one. Bye.